Hi, my name is Victor and I am a product manager here at GitLab, and this video is to prepare, let's say, non-engineering people, product people, designers, and whoever else interested to think about Kubernetes and to be able to consider it for various products they want to build. It will not go into detail about networking and role-based access controls at all. Instead, we will focus on the core principles and approaches built into Kubernetes and their enabling powers. Now, this is part 2 of the series, and I'm going to skip over the first half. So if you haven't seen it, then watch that. And let's start with part 2. So, we already spoke about declarative nature of Kubernetes. And actually, so to say, the user interface of Kubernetes is just REST API that consumes YAML resource definitions. These YAML definitions follow what we call the Kubernetes resource model. It's well-defined and extensible with some clear principles to follow. I already spoke about the declarative nature, but I would like to repeat again that these resources typically capture the desired state. At the same time, within Kubernetes, they will be enriched by the observed state too, what you can see here in the spec and status field. The mentioned API is easy to navigate as shown below. Moreover, it's even used internally within the cluster. So while the resource definitions and status are actually stored in a persistent layer within the cluster, typically an etcd database, controllers should not access the database directly, but they communicate with the API too, and that's how they learn about other resources inside of the cluster. Besides the Kubernetes resource model, the next topic we should understand, I will go back because I forgot something. One very important thing here is that the API is actually extensible. I will speak about this a little bit more later, but you might imagine how to extend it there. You see this prefix, group, version, namespace, and so on, path. What if you can change the prefix? What if you can define a new group, a new version? And all these things enable you to have an extensible API within Kubernetes itself. So, how does this desired state actually works? Behind all of that, there is the reconciliation loop. It compares the current state with the desired state, and there are controllers that act to reach that desired state. This has some immense benefits, like automated configuration drift remediation and auto-healing whenever needed. You can read more about controllers and the provided link. Speaking about auto-healing and the reconciliation loop, it's worth taking a look into how the state-based approach works within Kubernetes. It's natural to think, at least to me, about actions and reactions when we want to design a system, and in the end, this way we would define an evented system. So that means that whenever an event happens, the system might react to those events, like an increased load or a change in a configuration. Kubernetes took a different approach. It's a levels-based system. And this, by design, provides increased resiliency. For example, in this drawing, when the first spike happens, the system might be too slow to react, and actually the system might be already back to its desired state by the time we can react to the event. On the other hand, if we are in a levels-based system, then simply no reaction will happen, because by the time we would start to react, it will be fixed. And this way, it provides resiliency, because the event-based system reacts even though the system got back to the acceptable state. On the other hand, if the system needs to react because it's an ongoing issue, then both the event-based system and the levels-based system can react. And of course, with the levels-based system, the question is how short the loops are when you check your levels, and how do you start to consume those levels, but that's a different question. So until now, we spoke about the main building blocks and principles behind Kubernetes. And one thing I mentioned is that the Kube API is extensible. How we extend the Kube API is called custom resource definitions, or short for CRDs. And this really enables us to define custom objects within the cluster. Moreover, we can connect custom resource definitions with custom controllers that will act based on those objects. Like the environment kind, for example, I showed on the very beginning of the first series, that would be a custom resource definition. Moreover, on top of the custom resource definitions and controllers, we can even build something that's called operators. And operators are meant to manage the full life cycle of Kubernetes resources. For example, the GitLab operator was released a few months ago, and it allows the installation of a GitLab instance. It's very important to understand the difference here, what an operator provides, because one could install GitLab into a Kubernetes cluster even without an operator. This was already possible for a long, long time. But the operator allows the installation, the upgrade, the management, and the teardown of GitLab instances. So it really manages the whole life cycle of GitLab within the cluster. And you can have your own operators for anything, because these are just custom resource definitions, these are just controllers. Everything uses the basic patterns of Kubernetes itself and its extensible API. As a result, with CRDs and controllers and operators, Kubernetes is actually a programmable declarative API. This is the real power of Kubernetes and something that we should start to leverage more within GitLab. I hope that by now you understand how companies might use Kubernetes to build their own internal platform. They can extend the Kube API with primitives like the environment kind that will do all the heavy lifting needed to set up, manage, monitor, and tear down environments. Especially mentioned on this slide, Crossplane, as it shows the power of Kubernetes very well. Crossplane is a relatively young project. The first public release was at the end of 2018, and it allows declarative infrastructure management using Kubernetes. That means that you already have a cluster, you install Crossplane on that cluster, and you can use Crossplane to spin up new clusters, or you can use Crossplane to spin up a Cloud SQL instance or anything like that. In this regard, it's very similar to Terraform, but with the help of the Kubernetes API and the reconciliation loop, it provides even more benefits than Terraform does, because Terraform needs a state storage where it stores its own state, like Crossplane received this from Kubernetes itself, and with the reconciliation loop, it provides automatic drift detection out of the box. Moreover, because it's part of your cluster itself with this single REST API driven by Kubernetes resource model, purely YAML-based, 100% declarative, it allows others to easily build upon the Crossplane ecosystem and extend it further. For example, to say that whenever I start a new review app, give me a new database for every deployment, and that database is an infrastructure as code piece. It might come from any cloud provider as well. Now, take a moment to think about how GitLab could operate in a fully declarative way. In that setup, there is no need to code a CI pipeline that tells what application will do a license check or vulnerability scan. Instead, you say that in order to move to deployment jobs, you require a scanned and signed artifact. You declare that give me these artifacts, and then the system has to figure out whether it can do that, or if it fails, then just tells you that, sorry guys, we are violating something here. And this makes it much easier for the developers to reason about the system. Of course, there's still someone who provides these controllers, these operators or CRDs, and that's typically the platform engineer, or GitLab itself, but that's a different question. Similarly, we could describe an environment and manage its whole life cycle integrated into GitLab and the cluster. Finally, I would like to share some more links if you like to learn by doing and would like to give Kubernetes a try. First, there is Rancher Desktop. It's a Docker desktop alternative. It uses a simple Kubernetes cluster that you can start using immediately. kubectl or kube controller is the main command line tool to interact with the Kubernetes cluster. Kindness is a terminal-based minimal Kubernetes dashboarding tool. Of course, we have the agent to connect the cluster with GitLab. And finally, I started to learn Kubernetes at this last link here. They start with very, very simple setups, and I think that the tutorials can be followed even without programming skills, actually. So I hope you found this interesting. If you have any questions, feel free to reach out to me, and let's start thinking about Kubernetes a bit more.